Today we'll be starting with the next section, which is electromagnetic waves as it is. Right. Topic itself is electromagnetic waves, and it is a part of the chapter electromagnetic waves. Right. Apo electromagnetic waves initially I had shown and figure, right? So I showed you how it is propagating, right? So if this is blue, that is this line or the graph which I have drawn is representing electric field, then the magnetic field will be like this, right? We saw that in the first video. I'm not going to repeat it again, right? So what do you mean by electromagnetic waves? Electromagnetic waves are actually coupled time varying electric and magnetic fields, as I told earlier, right? That is, electric field is varying with time and it will give rise to what is known as magnetic field, right? And this magnetic field, if it is varying then with time, then it can again rise electric field, right? And the process continues on. So that's why it is propagating like a waveform and goes on continuously, right? These electric and magnetic fields are time varying and coupled with each other, and when they are propagating in space, this gives rise to electromagnetic waves, as the figure is showing, right? So I hope you, this is electric field lines, this is magnetic field lines, right? Now magnetic field, if I say, both of them are actually sine wave, right? So but if this is the propagation, right, so each wave which is a sine wave is perpendicular to the propagation, right? The magnetic field is actually perpendicular to the electric field, right? So these both are giving what is known as electromagnetic field. What the electric field as well as the magnetic field coupled form electromagnetic field. If the electric field is along x direction, right, if I'm taking this electric field is in x direction, the magnetic field will be in y direction and the propagation will be in z direction, right? See, I can depict it properly. See, this the propagation way. Let's say this is z, right? Now this is our electric field, right? So electric field, I am taking it as, suppose, this direction, right? It is propagating, that the motion or displacement is in this direction. Let's say this is x, so the z is the propagation direction, so obviously this direction will be y. So see, our magnetic field is in this direction, like this, right? See, so this is in y direction, which is magnetic field. Electric field is in x direction and z is in z direction. Sorry, the propagation of this entire system of electromagnetic waves in z direction. So I know x is perpendicular to z, y is perpendicular to z, or I can say x is perpendicular to y is perpendicular to z, or I can say in x direction what is happening. In x direction, our electric field, so electric field is perpendicular to y direction, I am taking magnetic field, is perpendicular to z direction, I am taking the propagation, right? So electric and magnetic field, which is time varying and coupled to each other, they give rise to electromagnetic waves. This much is clear, right? Now let's move on, guys. What are the sources of electromagnetic waves, right? So let's drag it. Now suppose the first source which you learned is acceleration of charges, right? The acceleration of charges radiates what is known as electromagnetic waves, right? Now suppose the charge was at rest, like this, right? So if it is rest, then electric field is static, right? Electric field is static, and if it is static, that means there is no dE by dt, right? There is no change, so there will not be any magnetic field. Electric field is not there, magnetic field is also not there. So if both electric field and magnetic field is not there, so there is no EM waves. Clear? Now let us take another condition. Suppose the charge is moving but with uniform velocity. Uniform velocity means the velocity is constant in value, or I can say acceleration is 0, right? Then the electric field is what? Constant. There is no change in it. Electric field is not 0, but it is always constant in this condition. If electric field is constant, then that is not changing with time, then that means magnetic field will not be there. So electric field is there but not the magnetic field. So obviously now I can say there is no electromagnetic waves. Clear? Now suppose now third condition, I'm going to take a charge which is accelerated, right? So to understand the motion of charge, let's take the motion of pendulum, right? Because it is having a bob at the end. So let's take this bob is acting as our charge. So just like the pendulum, it is moving to and fro, or I can say the charge particle is undergoing oscillatory motion, right? Hence electric field will be also oscillating in nature, right? Then this generates the oscillating electric field will generate oscillating magnetic field, right? And again oscillating magnetic field will again generate oscillating electric field, again oscillating magnetic field, and this process goes on, right? That is, it is like propagation of wave. That is, there is a regeneration of electric and magnetic fields, right? Regeneration, one is generating magnetic field, then magnetic field, again electric field, like that. Regeneration of electric and magnetic field is going on, and is just like a propagation of wave, right? And even in the previous class, that is in the 11th class, we know that wave motion is actually a particle's disturbance, right? Or the particle is displacing from its x position, or displacement is in the y direction. That is, each particle or the particle, if this particle gets an energy from the previous particle, so it gets displaced from its mean position. Similarly, the energy is transferred to the next particle, again it is getting, right, displaced. So I can say it is actually a disturbance. So what is a wave? It is actually a propagation of disturbance, right? Similarly, similarly here there is a propagation of field, of what electric and magnetic field are changing, right? So if it is in wave form, so obviously the electromagnetic waves will have frequency. So what will be frequency in this case? Frequency of electromagnetic waves, it will be frequency of the oscillating charge, right? Clear? Right. So see, so what type of charge produces electromagnetic waves? A charge which is accelerating. A charge which is not having acceleration, that is, which is having velocity constant, will not generate electromagnetic waves. Similarly, a charge which is not at all moving, there is no motion, also cannot produce a electromagnetic waves. Only a charge which is accelerated is produced, or it is generating electromagnetic waves. Clear? Now you are asked, what is the nature of electromagnetic waves? The next heading is nature of electromagnetic waves. Now that you have to know the difference between a transverse wave, spelling wrong, transverse wave and longitudinal wave. You have learned in your 11th class. So what is a transverse wave? Right, suppose this is our wave, right? So the propagation is in this direction, let's say x, whereas each particle is displacing from its mean position in which direction? Y. That is, each particle in the wave is moving, see, each particle is moving in the what direction? Propagation is in the x direction. So each particle in the wave is moving perpendicular to the direction of propagation, right? Those type of waves we termed as transverse wave, right? Now what is a longitudinal wave? Right, there is compression and rarefaction. So when you give sound here, the particles here will be compressed, then this will be rarefaction. So this is compression. So each particle will collide with a particle like this, and then this particle will collide with the other particle like this, right? So this is how the each particle is moving in x direction, and the entire wave is also moving in x direction. So particle is moving in the same direction as that of the propagation. This type of wave is known as longitudinal wave, right? And just now we have drawn the waveform of electromagnetic wave. So you can easily say electromagnetic wave is transverse in nature. Clear? Right. Right. So that means if I am writing, right, wave nature form, so electric field Ex, right, I can write it as, it is in sine form, sorry, wave form, right, E naught sine kx minus omega t, right. Similarly, magnetic field is in y direction, if it is, right, if I am taking E in this direction, right, B in this direction, and the propagation is in this direction, right. So by is equal to b naught sine kx minus omega t. And what is the value of k? Do you remember? K is equal to 2 pi by lambda, where lambda is the wavelength of a wave, distance between one crust and the other crust, right? Clear? Now the next small topic which we are going to take is energy in electromagnetic waves. Energy in electromagnetic waves, right? Now electromagnetic waves is a combination of electric field or electric field waves and magnetic field waves, right? So electromagnetic waves total energy will be contribution from here as well as here due to both electric as well as magnetic field, right? So let us consider, right, let the energy stored per unit volume of an electromagnetic wave, I'm going to write it as ET, right. ET is the energy stored per unit volume, or you can write it as energy stored per unit volume, like this, right. Now that means this ET, right, I can write it as just like this, energy stored by electric field by volume plus energy stored by magnetic field by volume, right. So what is energy stored by electric field per unit volume? You have learned it is half epsilon naught E squared, right. What is energy stored by magnetic field per unit volume? You have learned it is half B squared by mu naught, right. Now you have learned in velocity selector, this velocity is equal to ratio of electric and magnetic field, right. So E by B, so right, so I can write ET, right, that is energy per unit volume half epsilon naught E squared, right, plus half, in place of B, right, in place of B I'm going to write E by C, right. So what will be this equation, right, I'm sorry guys, my dog is barking like anything. A squared by C squared divided into 1 by mu naught, right. In the previous video I have also written, remember, C experimentally has been proved is equal to C is equal to root mu 0 epsilon naught, right. This was actually found by Hertz, okay. So this formula is constant, that is velocity of light is equal to 1 by mu naught, that is permittivity of free space, and mu naught is permeability and epsilon naught is permittivity, right. So this much is known. Okay, I have a confusion, I don't know, always it have the confusion. Anyways, so energy per unit volume half epsilon naught E squared plus half, now in place of C squared, so this C squared becomes mu naught epsilon naught, so here I can write E squared divided by 1 by mu naught epsilon naught into 1 by mu naught, right. Again, don't mind the barking of the dog, epsilon naught E squared plus half, this goes up, right, so E squared mu naught epsilon naught divided by mu naught, so this mu naught cancels out, so you will get half epsilon naught E squared plus half E squared epsilon naught, so these are two functions same, right, so half plus half becomes 1, so I can write energy per unit volume is epsilon naught E squared, or I can write it as E squared epsilon naught, same, right? So energy stored per unit volume by an electromagnetic wave when it is traveling from one place to another is given by Et is equal to epsilon naught E square. Clear? Right. Now, what and all are the properties of electromagnetic waves? So, first property, write it down as points itself, guys. So, properties of EM waves. I don't know why the dog is barking. Okay, the first point is velocity of EM wave in free space, right? It was found fundamentally, and it was found by Hertz. It was found that C is equal to 1 by mu naught epsilon naught, right? Velocity of light or velocity of EM wave. Light is a type of visible light is a type of EM wave itself. So C is equal to 1 by root mu naught epsilon naught, where mu naught is again permittivity of free space and epsilon naught is permeability of free space, right? Again, I am telling Hertz was a person who proved it. This is something which was experimentally done, guys. It is not actually a theoretical section. Okay, next medium or broad point is no medium is required by an electromagnetic wave to travel from one place to another. See, our mobile waves or your FM radio waves, right? Or your radio signals, all it just travels through air, so it doesn't require any medium to travel. Clear? And similarly in vacuum also, right? That's why you are able to hear thunder even if there is a lag, right? Now, but it can also propagate in medium. If medium is there, then also it can propagate. So medium is there or not, EM waves can propagate easily. And if the velocity or if the EM wave is propagating through a medium, then the velocity of that EM wave is given by, it is not C because it is not air, is equal to mu epsilon, where mu is the permeability of the medium and epsilon is the permittivity of the medium. Clear? Now, the next point, that is property of EM waves, is EM waves can or we carries energy, right, as you found, which is Et is equal to energy per unit volume is epsilon naught E square, and also it is having momentum. It is having energy observed, then obviously it is having momentum because momentum is mass into velocity. So particle nature, mass is there, velocity, speed with which it is moving. Clear? I don't know why it is barking like anything. രാത്രി ചെയ്യുന്നതിൻ്റെ പ്രശ്നം അയ്യോ next last point, electromagnetic waves exert pressure. ഒരു എക്സാമ്പിൾ എന്തറിയാം, sun, right? Sunൻ്റെ താഴെ നിങ്ങൾ നിൽക്കുക, you are just standing before sun, so it is providing heat, right? This heat is infrared radiation actually, right? It is having high heat capacity and it is actually exerting energy to your palm, right? Heat energy. Energy is there means work is done. Work is done means obviously a pressure has been exerted. So electromagnetic waves can exert what is known as pressure. Next topic which I'm going to take is electromagnetic spectrum, right? So spectrum means it's just like means a collection or a band, right? So electromagnetic spectrum is actually classification of EM waves according to their frequency or wavelength. That is, you are having multiple around, you have to learn around 7, right? So these 7 waves or electromagnetic waves, if they are arranged in the level of their higher to lower or lower to higher, if they are arranged in frequency range and wavelength range, that type of arrangement or classification is known as electromagnetic spectrum. That is based on wavelength, EM waves can be classified in different categories, and this classification is known as electromagnetic spectrum, right? So different categories of EM waves we are writing in the decreasing wavelength. Okay, the first one is radio wave and its wavelength is greater than 0.1 meter, right? So it is has the highest wavelength. So decreasing order I'm going to write. The second one is microwaves, right? Microwaves are having the wavelength of 0.1 meter to 1 millimeter range, right? And the third one is infrared, right? Infrared radiation has a range of around 700 nanometer, right? And the next is our visible light. That is fourth one, visible light, right? Visible light is from 700 nanometer to 400 nanometer, clear? And the fifth one is ultraviolet, UV, that is 400 nanometer to 1 nanometer. Similarly, sixth one is X-rays. X-rays is from 1 nanometer 10 to the power minus 3 nanometer, right? Similarly, the seventh one is gamma rays, and gamma rays range is less than 10 to the power minus 3 nanometer. So least wavelength is gamma rays and highest wavelength is radio waves. So you know that wavelength is inversely proportional to frequency. So gamma rays has the highest frequency and radio waves has the least frequency, clear? Now these 7 waves together are constituting the electromagnetic spectrum, right? Sometimes it is very difficult to remember this entire form, or I can say which is having maximum wavelength, etc. If you are asked, it is difficult, or you can say whether UV rays is having higher wavelength than X-ray. You cannot know if you don't know the order, right? So you can either remember by the alphabet like this: R, M, I, V, U, X and G, right? So the R is having maximum wavelength and G is having minimum wavelength, right? Or you can remember like this: red man in violet uniform has X gun. This is just a simple way. If you want, you can remember, clear? Right? Then electromagnetic spectrum and the diagram etc. is there in your textbook, so please understand it and do it. Okay, now so guys, after this there is an entire ray. Actually the topics like this, that is radio waves, what is its application etc., then microwaves etc. There's these 7 waves application etc. has been mentioned in your textbook. Please study it by yourself. It's a pure theory, guys. Doesn't miss. Usually it is given as an assignment. So your homework after hearing this video class is to write the entire notes on the entire waves, the 7 waves I have given, right? Read your textbook and write about radio waves in your notebook and submit it. Yeah, that is your homework. Okay, because it is something which you have can read and understand. Clear? Now let's do a small problem, guys. Ouch. Right, there is a radio can tune in to any station in the range of 7.5 megahertz to 12 megahertz. Right, what is its wavelength band, corresponding wavelength band, right? So that means minimum frequency is 7.5 and maximum frequency is 12 megahertz, right? And what do you mean by speed of light is 3 into 10 to the power 8 meter per second. This is something you have to know. Okay, then what will be the corresponding wavelength, lambda 1? It will be C by frequency, first frequency. So 3 into 10 to the power 8 divided by 7.5 into 10 to the power 6 mega, right? So you will get 40 meter as answer. That is the first wavelength, right? That is the highest wavelength for least frequency. Then lambda 2, that is C by mu 2, that is equal to 3 into 10 to the power 8 divided by 12 into 10 to the power 6. You will get the answer as 25 meter, right? So that means the wavelength range is how much? From 40 meter to 25 meter. This is highest wavelength, this is lowest wavelength. Clear? Simple, right? So the band of wavelength is found. The next question is, in plain electromagnetic wave, the electric field is oscillating sinusoidally in the frequency of 2 into 10 to the power 10 hertz. Right, electromagnetic wave, and the amplitude is 48 volt per meter. Right, so your first question is, what is the wavelength of the wave? Second one, what is the amplitude of the oscillating magnetic field? And you're asked the third question, show that the average density of E field, that is electric field, equals to the average density of the magnetic field. Right, so you are supposed to find first the wavelength of the wave, then the amplitude of the oscillating magnetic field, and the third is asked whether you have to show whether the average energy density, that is energy per unit volume, of electric field is equal to the average energy density of magnetic field, and it is given the speed of light is c is equal to 3 into 10 to the power 8 meter per second. Yeah, now let's do it. Why it is not moving? Now, first section, what and all is given? You are given frequency as 2 into 10 to the power 10 hertz, and electric field amplitude E naught is given as 48 volt per meter, and your given speed of light is 3 into 10 to the power 8 meter per second. Now first you are supposed to find wavelength. Lambda is equal to c by mu. Right, so what is c? Is 3 into 10 to the power 8, and what is frequency? It is also given 2 into 10 to the power 10. Right, so you will get 0.015 meter as the wavelength. Clear? Easy. Now let's move on to the second part. What has been asked? You are asked what is the magnetic field strength. Right, you know what is the relationship of C? C is equal to E by B, or I can write as E naught by B naught. Now what is E naught given as? It is given as 48. What is E naught is given as how much? 48 itself, right? And B naught is to be found, and C is given, right? 3 into 10 to the power 8. Right, then what is B naught? B naught is equal to 48 divided by 3 into 10 to the power 8. That will be equal to 1.6 into 10 to the power minus 7 Tesla. Clear? Now let's move on to the third part. What has been asked? You are asked to check the energy density. Now what is the energy density of electric field? Half epsilon naught E squared. Right, and energy density of magnetic field is, or UB, I can write it as UB, is B squared, or half B, why it is not writing? UB I am writing here. UB is equal to half B squared mu naught. Right, now you know E is equal to CB. Right, and also you know C is equal to 1 by root of mu naught epsilon naught. Right, you know this one as well as this one. Right, now you are putting this value here. Right, so I can write E is equal to E is equal to, or okay, I'm substituting E is equal to, why it is not writing? E is equal to 1 by root mu naught epsilon naught into B. Right, now I'm going to square the both sides. Right, so that becomes E naught square, this one squared, as well as B squared. So let's bring, or I can write E squared is equal to 1 by mu naught epsilon naught B squared. Right, clear? Or I can bring epsilon naught to the one side, so that it becomes epsilon naught E squared is equal to 1 by mu naught B squared. Right, let's put half in both the sides, this one half and this one half. Right, so this is UE, and this is UV. So you just proved that energy density in electric field and energy density in magnetic field is equal. Clear?